Let's continue the questions. So question number 41. One cosmic year equals to how many years? One cosmic year equals to how many years? Option A says 250 million years. Option B 150 million years. C 350 million years. D 100 million years. Let's see the explanation. What is this cosmic year? We know one solar year. What is solar year? It is the 365 days revolution of the earth around the sun. Similarly, the sun is also not constant. It is also revolving around the Milky Way galaxy. The sun along with the entire solar system, it is revolving around the Milky Way galaxy. So it will take nearly 250 million years to go one complete revolution around the Milky Way galaxy, which is called as the one cosmic year. Okay. So one cosmic year equals to 250 million years. It is a time taken by the solar system to go one complete revolution around the Milky Way. From the beginning of the solar system, or from the origin of the solar system, so it has revolved around the Milky Way galaxy 20 times. Okay, so this is the information. Clear? Question number 42. Our solar system revolves around the entire Milky Way galaxy. So right now we discuss. So at what speed is it moving? So option A says 7,20,000 kilometers per hour. B 5,50,000 kilometers per hour. C 8 lakhs kilometers per hour. And D option 6,30,000 kilometers per hour. So we know. So it is revolving around 8 lakhs kilometers per hour. So with this speed, it is completing one revolution around the Milky Way galaxy. So once in 250 million years, which is equals to one cosmic year. Okay. So its correct option is option C, 8 lakhs kilometers per hour. So now right now we are moving at a speed of 8 lakhs kilometers per hour. Next one, what is the study of sun is called as? The study about sun is called as option A says helioseismology, B solarography, C stellology, D heliology. Almost all the options look similar to each other, but the correct option is, let's see, the study about sun. So its a keyword is helioseismology. It is also called as the heliophysics, but this helioseismology word is coined by the scientist called as Douglas Goff. The science of studying the sun and its influence throughout the solar system is called as the heliophysics. And the helioseismology is the study about the structure and dynamics of the sun through its oscillations. Clear? So both the words we can use, but the right option is option A, helioseismology. Clear? Question number 44. Which of the following layers of the sun will be visible only during the eclipse? We know solar eclipse and lunar eclipse. And during solar eclipse, which of the following layers of the sun will be visible? Option A says corona, option B radiation zone, option C photosphere, and D chromosphere. Let's see the explanation. Okay. So this is the situation we'll see during the complete or total solar eclipse. So we know here will be the sun, here will be the moon, and here will be the earth. During this solar eclipse, moon comes between the sun and earth, and the moon will block the sun from the perspective of the earth. So during this situation, only the outer layer of the corona, outer layer of the sun corona will be visible. Only during total solar eclipse only it will be visible. Okay. So it's option A, corona. It is nowhere related to your coronavirus. Okay. So corona is the outer layer of the sun. So question number 45. What causes solar spots and solar explosions to occur on the sun surface? We know sunspots and solar spots, explosions. So option A says the difference in the nuclear fusion reaction. Option B says the difference in the magnetic energy and temperature of the sun. Option C says both A and B, and D none. Okay, let's see. We know the surface temperature of the sun. It is nearly 6,000 degrees Celsius, and it's at the core it is 1.5 crore degree Celsius. So because of this high temperature only, it is the nuclear fusion reaction is occurring. Because of the nuclear fusion reaction only, it is emitting the heat and light, which we call it as the solar energy or the solar radiation. So there will be a differences in the nuclear fusion reaction. So because of the difference in the nuclear fusion reaction only, we can see the dark patches. These dark patches indicate the low temperature on the sun surface. The average is 6,000 degrees, but there are some sunspots which indicate the difference in the temperature. Why the difference occurs? Mainly because of the nuclear fusion reaction and difference in the magnetic energy of the sun. So it is option C, both A and B. Okay. Question number 46. What is an astronomical unit? Option A says the time it takes for the solar system to orbit the entire galaxy. We know it is cosmic year, but it's not the right option. Next, measurement of the size of the solar system. Next option is the distance between the Earth and the Sun, and the measurement of the size of the planets. Okay, let's see the explanation. So what actually is one astronomical unit? So it is the actual distance between the Sun and the Earth. We know it is exactly 150 million kilometer. This distance is called as the one astronomical unit. Again, this distance is not common. So it will vary up to 147 to 152. This is called as the perihelion and this is called as the aphelion. The average distance it is called as the one astronomical unit. Clear? So it is the distance between the Earth and the Sun. Option C is correct. Question number 47. Which of the following sentences is correct? First is, the Sun rotation speed is more than the revolution. 2. Sunlight will take exactly 8.3 minutes to reach the Earth. Third statement, the Sun is a very massive star. Okay, so let's see. So what is the rotation speed of the Sun, the revolution speed of the Sun? We know that Sun will take exactly 27 days for the one complete rotation on its own axis, and it is 250 million years for one revolution or one cosmic year. 250 minutes it is the time taken by the Sun or the solar system to go one complete revolution around the Sun, Milky Way galaxy. So compared to 27 days, 250 million is very larger. So that means the rotation speed is more than the revolution. No, Sun rotation speed is lesser than the revolution because it is 27 days and it is 250 million years. So that's why statement 1 is incorrect. Next, sunlight will take exactly 8.3 minutes to reach the Earth. So this is correct. And Sun is a very massive star. No, Sun is a very minor star. Compared to UY Scuti and Canis Major, it is a very minor star. So that means, according to the given explanation, Sun rotation speed is lesser than the revolution. Sun will take exactly 8.3 minutes to reach the Earth, and Sun is a very minor star. So let's continue with the question number 47. Which of the following sentences is correct? Option 1 says Sun rotation speed is less than revolution. Sunlight will take 8.3 minutes to reach the Earth. The Sun is a very massive star. Okay. So let's see the explanation. So we know that 250 million years is the time taken by the Sun or the solar system to go one complete revolution around the Milky Way galaxy. Whereas Sun hardly takes 27 days for complete one rotation on its own axis. So that's why Earth rotation speed is less than Sun's rotation speed is less than the revolution speed. So that means, according to the given explanation, statement 1 is correct. Sun rotation speed is less than the revolution. It is 27 days, it is 250 million years. Okay, so that's right. Next, sunlight will take 8.3 minutes to reach the Earth. It is a correct statement. Then, the Sun is a very massive star. No, Sun is a very medium-sized star. Compared to UY Scuti, the UY Canis Major, it is a very minor star. Okay, so that's why third statement is incorrect. First statement is correct. Second statement is correct. So according to the given explanation, only B is correct. Next one, what is Chandrasekhar limit related to? Very interesting question. The minimum size that a celestial body must have to be called as a planet. Next one, the limit for the sunlight and its gravitational influence. Option C says the minimum size that a star must possess to turn into a black hole. Next one, the minimum speed at which an object must travel to escape from the Earth's gravitational pull. Okay, so it is completely related to black hole. So meet Mr. S. Chandrasekhar. Okay, so he is the Indian astrophysicist. Basically, Tamilian, but born and brought up in the Punjabi family, so Punjabarian. So he stayed in the USA and he received the Nobel Prize. He received the Nobel Prize in the year 1982 for his work towards the life cycle of a star. So he is the person behind the discovering the black holes. how the stars will turn into black hole. What is the minimum? Says that the star must possess turn into black hole. So according to his explanation, any star which is more than 1.4 times the mass of our sun can turn into black hole or neutron star. So it may be up to 3 times also. If it is between 1.4 times to 3 times, it will end up as the black hole or the neutron star. Within this range, it will be a neutron star. If it is more than 3 times the mass of the sun, it will turn into black holes. So this limit is given by the S. Chandrasekhar. So it is popularly called as the Chandrasekhar limit. So according to the explanation, it is the minimum size that a star must possess to turn into black hole. It is 1.4 times the mass of our sun. If it is more than this, it will turn into either neutron star or black hole. Okay, so option C is correct. Next question number 49. Consider the following sentences related to auroras. Okay, so they can be found on all internal planets just as they are. Next, they are formed by the fusion of the Earth's magnetic field and the sun's solar winds. Option C says these can be seen through telescope on certain special days all over the Earth. Statement 4 says at the North Pole they are called as the aurora australis and at the South Pole they are called as the aurora borealis. So which of the following statements are incorrect? The question is demanding the incorrect statement. So let's see the explanation. This is how the auroras look. How these are created? It is mainly because of the Earth magnetic field. We know that within our inner planet system, Mercury, Venus, Earth and Mars, only Earth exhibits this kind of the auroras. Not even the Mercury, not even the Venus, not even the Mars, because they lack the nickel and iron content at their core. So that's why when the solar winds coming from the sun, when they meet with the Earth's magnetic field, they create this kind of the colorful radiations. This can be seen in the ionosphere at an altitude of nearly 120 kilometers. These are called as the auroras. Generally, these are called as the aurora borealis in the North Pole and aurora australis in the South Pole. Because as it is very close to the Australia, so it is called as the aurora australis. It can be seen only in the Earth. Within the inner planets, it is only seen in the Earth, not in any other planet. Okay. So, according to the explanation, they can be found on all internal planets, no, except Earth, not other any planets. But they can be seen in the Jupiter and Saturn. Okay, that's interesting. So, first statement is incorrect. According to the given explanation, they can be found on all internal planets, just as they are. No, except Earth, no other planets. Except Earth, no other planets can be visible. You cannot see the auroras, but they can be seen in the outer planets, just like the Jupiter and Saturn. Okay, so first statement is incorrect. They are formed by the fusion of the Earth's magnetic field and the fusion of the solar winds. So second statement is correct. Next, these can be seen through a telescope on certain special days all over the Earth. No, not through any telescope. We can see with the naked eyes only, but no, not on the special days, not all over the Earth also. They can be seen only in the poles. Okay, so that's why third statement is also correct. Next one, at the North Pole, they are called as the aurora borealis, and in the South Pole, they are called as the aurora australis. So as they are interchangeable, so fourth statement is also incorrect. So fourth one incorrect, third one incorrect, second statement is correct, first statement is also incorrect. So the question is demanding which of the statement is incorrect. So according to the explanation, 1, 3 and 4. Okay, so 1, 3 and 4 are incorrect. Only second statement is correct. Yeah. Next, arrange the following celestial bodies in order based on their time of their formation. The question is demanding the chronology of the solar system formation. So 1, star, 2, nebula, 3, planets and satellites. Okay. So basically we know that around 14 billion years ago, the Big Bang took place. So from this Big Bang, around 6 million years ago, 6 billion years ago, the nebula started. From this nebula, the stars were born. After the birth of the stars, the planets started to evolve. After the planets formation, the satellites were formed. Okay, so this is the chronology. So according to the explanation, nebula should come first, then comes the star, then comes the planets and the satellites. So nebula 2 must be 2, then comes the star, 3 planets, 4 satellites. So option B is correct.